Hello again and welcome to Astronomy Toronto. My name is Randy Attwood. Astronomy Toronto is Southern Ontario's quarterly astronomical news magazine seen here on Rogers Cable 10. Astronomy Toronto is also produced by the Toronto Centre of the Royal Astronomical Society of Canada, an organization for both amateur and professional astronomers right across the country. Well, this is the summer 1989 edition of Astronomy Toronto, and today we're going to be looking at amateur astronomy. We'll see what it was like for one of our guests to observe the southern skies from Australia in late last year. We'll also look at what we can see in southern Ontario this summer. There's a lot of things to see in the summer sky, especially if you get out of the city, and there's an extraordinary lunar eclipse visible from southern Ontario this summer. We'll get the latest on that. My guests today are two very well-known amateur astronomers. First on my left here is Terence Dickinson, who is an astronomy author and is also writes a weekly column in the Sunday Star. Terry, thank you very much for coming.
My pleasure.
I should mention that Terry has written a book called Night Watch, which is you have to read it if you want to get into astronomy. Night Watch is it's in its 7th printing now, I believe. It's a wonderful book. I'm sure many of our viewers have seen it. Beside Terry is Michael Watson, member of the Royal Astronomical Society. I should mention that both my guests are members, and Michael is not a professional astronomer, but he's one of Canada's, I would say, foremost amateur astronomers and astrophotographers. Thanks, Michael.
Good to be here.
I should mention, too, that this is about the 10th time that Michael's been on Astronomy
I think that's
Toronto.
right.
I appreciate you both being here today. Today we're going to be talking about amateur astronomy. My first question to you, Terry, is how did you get started in amateur astronomy?
I was 5 years old. Maybe I was born interested in astronomy, I don't know, but I was out walking in Leaside, a suburb of Toronto, with my uncle. We saw, it was at night, we saw a meteor go across the sky, and I said, "Uncle, what's that?" And he said, "It's a falling star." And I can remember being curious, even back that far, at what this object was. And he said, "Stars just fall." And then I was, as a little kid, out looking at the stars, wondering when the next one was going to fall. And ever since then, there's been an attraction. And when I was old enough to read, I devoured the school library, asked everybody questions, and visited the observatory, the Dunlap Observatory. That was a big step in it. And bought my first little refractor telescope that got me started. And all of those things were with me right from the beginning. So I have to say I'm sort of a born amateur astronomer rather than born again.
Michael, I'll ask you the same question. Where did you get your start?
Well, I really got interested in amateur astronomy in 1970, just at the end of high school, but I have a memory much earlier, just in the summer, just before I turned 9 years old. I remember that there was an almost total lunar eclipse. I've looked back at the records to figure out exactly when that was since that time, and we're up at the cottage in Muskoka. It was the summer of 1961, and my father, who knew all about these things, I thought, you know, for some reason, I didn't know how or why, told me that that night there was going to be an eclipse of the moon. He explained what it was all about, and I went to bed, and then he got me up, and it was the most extraordinary thing, because just like he said it, exactly when he said, the moon started to move into the Earth's shadow. And that's my first memory, and then I guess it lay dormant for a number of years, but I remembered it later, and that's how I really got involved in it.
Well, Terry, your weekly column in the Sunday Star really looks at what amateur astronomers do and what people who haven't been introduced to astronomy can look for. Do we know how many serious amateur astronomers are in Canada?
I've wondered about that, and the best number I can come up with is about 30,000. And I base that on two things. One is I've talked to all the people who sell astronomical equipment in Canada and get an idea of how much they sell and how many people they must be selling it to. And the second thing is there has been a study done in the United States. There's about 500,000 amateur astronomers there, so we take approximately a tenth of that, maybe a little bit less. 30 to 50,000, I would say, would be people who would definitely call themselves amateur astronomers. They go out a couple of times a year minimum to look at the sky, learn more about the constellations, watch an aurora, an eclipse, things like that, ranging all the way from there to people who take it extremely seriously. We have examples of Rolf Meyer in Ottawa, who's discovered 4 comets, the most of anyone in North America, or at least equal to anyone in North America. That's on one end of the spectrum, and then the casual observers and everything in between.
Michael, how would you categorize yourself? I look at you as being a very serious amateur astronomer.
I think that's probably right. I'm certainly not in the class of Rolf Meyer, and I think there are a couple of reasons for that. Not only for me, but for a lot of astronomers. One is something that is a problem in southern Ontario and indeed all through the developed world, and that is light pollution. I happen to live in the city, and we can contrast that with Terry, who lives a distance outside Kingston, but under dark skies. For me to do any really serious work, apart from just casually looking up at the planets and the moon, I've got to drive an hour and a half or 2 hours outside of Toronto, and that's a real problem for people in Toronto. So that's one of the problems, and of course that's why I, for example, when I can go to Australia, we'll be talking about that a little later, to do some serious astronomy. So that's one problem. And the other thing is time. You know, Rolf devotes an enormous amount of time to his pursuit. It's almost you can't really call it a hobby so much anymore. With me, it's a hobby, and I do take it seriously, but I'm not able to devote that much time to it.
Yeah, there's another difference too, and that is the people who take it on seriously to make a discovery like Rolf, they go on a rigorous schedule, and in certain cases, that's all they do is look for comets or look for supernovas. And to me, amateur astronomy, I mean, that is certainly a category of amateur astronomy in which fame and important discoveries can come. But then there's the other aspect that more amateur astronomers partake in, and that's enjoying all the phenomena that the sky presents. And what you mentioned earlier is important, because some people, fortunately like myself, can just step outside in the backyard, they've got that nice sky. And then many others, I'd say probably 60% of Canadians, are faced with the problem that there's lights all around where they live, and they have to make an effort to do it. So there's not only are people trying to do different things, but they're faced with different situations where sometimes they can and sometimes they can't conveniently.
Terry, you as a professional astronomy writer have had an opportunity recently to get away from city lights and go to the southern hemisphere into Australia. You're commissioned to write an article about astronomy in Australia. Tell us about what you saw and what you did.
I had a terrific experience and was at the Anglo-Australian Observatory and some other places where I got great dark skies. And are we going to show some pictures?
Let's look at the first picture here.
Okay, because this gives an example of some of the things that you can see in the southern sky. This is what's called the Large Magellanic Cloud, and it is a galaxy that is the nearest galaxy to our own Milky Way. It's a small galaxy, and it's where the supernova exploded 2 years ago, which you talked about on Astronomy Toronto. This is a closer shot. These two pictures I took in Australia, and was amazed when I got back. I took them with a regular camera and a 90mm and 200mm lens, and the skies are so dark. They're darker than I've seen anywhere here. Just magnificent. You can see this galaxy easily with the unaided eye. In binoculars, just as seen in the pictures here, you can see individual stars within it, and that orange blob is the Large Magellanic, the Tarantula Nebula within the Large Magellanic Cloud, a region where stars are forming, and the supernova is just beside it.
Terry, how big would the full moon be in this picture?
Be smaller than the Magellanic Cloud. So this is a big object. Looks like a chunk of the Milky Way that's disconnected, but really it is a satellite galaxy of our own Milky Way. This is if there's a Large Magellanic Cloud, there's got to be a small one, and this is the small one, taken on the same scale as the previous picture. And just off to the left is both of these things you just can't see in the northern hemisphere, and it's unfortunate, but it's nice to show them here to let people know what's visible in the southern hemisphere. Off to the left is a globular cluster within our own galaxy that happens to be in the same line of sight as the small Magellanic Cloud. So the cloud is a little galaxy, about 200,000 light years away, and the cluster there on the left is 47 Tucani, which is a globular cluster of about 1 million stars, about 25,000 light years away. So you get these two objects, both visible with the unaided eye, terrific in binoculars and telescopes.
Very nice to photograph as well.
And here we have a bright section of the southern Milky Way. Now Michael's going to talk a little bit about this in a moment, I know, because I've seen his pictures, and they're just astounding.
Well, this is Michael Watson's favorite object. I think everyone knows that.
Oh, well, I stole it because this is my picture of his favorite object, and he's got pictures every bit as good and better than this, showing the Eta Carinae Nebula, which is visible to the unaided eye.
Quickly, but before we go on,
Sure.
what does Eta Carinae mean? Why would it?
Okay, Eta Carinae is some stars are named with Greek letters and in constellation names,
Okay.
like Alpha Ursa Majoris, which is the first star in Ursa Major. This is Eta, which is the fifth or sixth brightest object in Carina, which is a bright southern constellation that we don't see here, but it's set in the Milky Way, and it's a magnificent area to see these nebulas and star clusters that you can see in this picture. So Eta was something that appeared fuzzy when they were naming the stars in the constellations, and they named it the same way they name a star. But you can see here that it's that red object, and it's really a cloud of dust and gas where stars are being born. So, but this sort of gives an idea of the binocular and naked eye view here of this extremely rich area of the Milky Way.
Something that's interesting about this object, and about a number of things, there's a lot of history associated with this object, because the star Eta Carinae has undergone spectacular changes in brightness over the last couple of centuries. Very dramatic and really remarkable. And Terry, as far as I know, to this day, not completely explained.
No, it isn't. It's sort of a half supernova and half variable star. It's a very interesting object that got up to be one of the brightest stars in the sky at one time. The object, the star right at the center of this.
Right. The next photo we have is of the Milky Way that Michael took. Michael, tell us a little bit about this wonderful slide.
One of the great things about traveling to the southern hemisphere, and Terry, you've seen it. I've been there now 3 times, and I guess by the time the show goes to air, I will have been there a 4th time. You get to see the center of our Milky Way galaxy, the bright, bulging center of our galaxy, very high in the sky, and much higher in the sky than we can see from the northern hemisphere. And you really see it in a very dramatic fashion, not only because it's high in the sky, but also from, for example, the outback of Australia, where this photograph was taken, from very dark skies, as Terry mentioned. And so you can see the center of the Milky Way, which is toward the left side of this photograph. And I should say that about 3/4 of this photograph shows a part of the sky that you can't see at all. It's always below the horizon from Canada. And we see the center of the galaxy toward the left, and then you can see dark lanes of obscuring foreground dark gas blocking out the light from the stars beyond, and then the constellation of Crux, the Southern Cross, right down to the lower right with the bright stars Alpha and Beta Centauri. And Terry, I think you'll remember about the time this was taken in April of 1986. Right in the center of this photograph is an interloper. And we all remember Comet Halley. Many of us, thousands of astronomers, both amateurs and professionals from the northern hemisphere, traveled into the southern hemisphere to get the best views of Comet Halley in April of 1986.
Terry, you were able to visit one of the large installations, astronomical installations in Australia.
One of the largest telescopes in the world, the Anglo-Australian telescope at the Anglo-Australian Observatory, in a beautiful location on a 4,500-foot plateau. They don't have really high mountains in Australia, but this is about 250 miles northwest of Sydney, where this telescope is located. A magnificently dark site. And you can get the scale here by there's an astronomer on the extreme right-hand side of this, and he's right beside the observer's cage where the astronomer climbs to run the instrument, which is at the focus of a great mirror, 154-inch mirror on the left side of this image of the observatory. And I met David Malin down there, and this is somebody who I think should be better known to amateur astronomers. David Malin is the world's greatest astrophotographer because he's got that fantastic telescope to use to take pictures, and he does. He's interested in taking beautiful images such as this for everyone to appreciate the universe. And this is the only observatory that has a full-time professional who takes photographs both for astronomical purposes and puts them together in these magnificent color images.
Tell us what we're looking at here and why is it such a wonderful photograph? It's it looks like a painting.
Indeed. Things like this just are inspiring just from the color. You really don't have to know what it is. But what we're seeing, the Horsehead Nebula, that prominent dark patch, is a cloud of dust and gas about a light year across, which is silhouetted against another cloud behind it, the red there, which is lit up. Now these are regions where stars will eventually form. They are giant masses of dust and gas within our own galaxy, collapsing, and this is how the sun was born and how other stars are born. They collapse, and then stars are born within them. And that process lights up the cloud and gives this beautiful image that David Malin took.
Wonderful.
This is Tom Cragg at the controls of the Anglo-Australian Observatory. Here's an example of someone who started out as an amateur astronomer and now is the controller of this one of the largest telescopes in the world. Just a really amiable person, extremely knowledgeable, who's taken many aspects of astronomy and put them together. There's many ways that people can come into the subject as amateurs or as professional research astronomers, or in Tom Craig's situation where he is the operator, chief technician, and manager of this telescope.
You had an opportunity to meet some interesting amateur astronomers in Australia.
Here's me and Bob Evans, and this I feel honored to stand beside this man. He has probably made the greatest recent achievements in amateur astronomy of anybody. He has discovered 18 supernovas, and what he does is he looks at galaxies. Not only does he look at galaxies, but he's memorized the appearance of objects tens of millions of light years away that look like little fuzzy patches in the sky. He's memorized the appearance of them and the stars around them. And if he sees a star in that vicinity that he hasn't seen before, it may be a supernova within the galaxy punching through and looking like a star. Now he has memorized the appearance of 1,000 galaxies, 1,000 of these little fuzzy patches, and the stars around them. And he's picked out, here's one of the brighter ones seen in NGC 2613, where he shows in these two pictures that he's holding how you can see in the left-hand one an extra star. That's probably a little more prominent than he saw it visually. That's the type of thing that he does. And he's discovered more supernovas than an automated system in California with a 30-inch telescope, a PhD running it, a whole bunch of graduate students, CCD camera, banks of computers running this telescope looking at galaxies for supernovas. This man, using a 10-inch telescope, probably worth about $800, has discovered more supernovas.
Now, it's important for professional astronomers to take a look at these supernovae as soon as they explode. Is that
exactly.
Right?
That's the whole idea, in that this is extremely valuable to professional astronomy because we understand more about supernovas with every new one that we can see, about how stars explode. It's a part of the big picture in the life history of a star. And seeing a star explode is a rare event. And if you can catch it right at that explosion and take a spectrum of it and measure its brightness, you can tell a lot more about this process.
You mentioned Rolf Meyer, an amateur astronomer in Canada who's discovered 4 comets. You also met an Australian comet watcher and discoverer.
This is Bill Bradfield, and Bill Bradfield has discovered 14 comets. He holds the record for the 20th century. I think there's only 4 other people in all of history that have discovered more comets than him, and he has to compete with more people looking for comets than anybody did in the past. So I would probably say that Bill Bradfield is the greatest comet hunter who's ever lived. And he uses a 6-inch telescope. I think it's about 60 years old, that he bought for $60. And he built a tripod out of scrap lumber. But he is solely dedicated to doing this. He started at age 43, started late. He's discovered 14 comets. He's 62 now, and he's still going strong. And being out all those nights and lugging the telescope out, he's in great physical condition. He doesn't need glasses. He's even discovered one of his comets with 7x35 binoculars. It's just an intensity of effort.
But he's out every clear night doing this.
He's out every clear night. He knows exactly what he's doing. That's all he does. And he and Evans have made magnificent contributions to science. And so it is possible. It is possible to do this. These guys are at the pinnacle of achievement. They are invited by professional astronomers, Evans, for example, is going to go to Spain for the next IAU convention, International Astronomical Union, where he's going to speak to the top astronomers in the world about how he, with his eye and his little $800 telescope, has picked up more supernovas than any professional system on Earth.
Wonderful.
It's an amazing story.
Great. And with that, I think we'd like to take a short break. We'll be back in a minute to look at this summer's sky and especially an extraordinary lunar eclipse. Stay with us. Welcome back. Well, the summer season is the amateur astronomer's favorite. We're out of the winter blahs. The skies are a lot clearer. It's a lot warmer outside to be outside with a telescope or binoculars. And every summer, Astronomy Toronto takes a look at what we can see in the night sky. Michael Watson, who has been telling what to see in the night sky every season, has prepared some information about the summer sky.
Well, summer sky, like you say, Randy, it's a great time to be an amateur astronomer because you can finally take off the parkas if you live in southern Ontario and put them away. One problem is that you got to wait a little later with daylight time and with the sun so high in the sky. It's actually quite remarkable, but for example, Toronto, the end of evening twilight doesn't actually occur until just before 11 p.m. And so it's not until that time that you actually get a completely dark sky. And then actually you only get about 4.5 hours of completely dark sky between the end of evening twilight and the beginning of morning twilight. But boy, there's an awful lot to jam into that 4.5 hours. And the summertime, of course, for North Americans is the best time to see the Milky Way. We've got a photograph here, a very wide-angle photograph of the Milky Way, the summer Milky Way, taken from Muskoka. And you can see that a panoply here of the entire Milky Way that you can see from the northern hemisphere spread across the sky from Cygnus on the constellation of Cygnus on the left all the way down to Sagittarius toward the center of the galaxy on the right. And interesting, if you think back then to the photograph that we showed earlier of the Milky Way taken from the southern hemisphere, you could sort of put that to the right of the screen and they would join up in the middle in the galactic center. And that gives you an idea of how the galaxy, the Milky Way, bulges toward the center and then sort of thins out toward the edges. And here we have, you can see among all of the thousands of stars here in this 45-minute exposure, the three brightest stars which form what we call and what's well known as the summer triangle. Vega, which is toward the top of the frame here, the brightest star. Then over to the left, Deneb in the constellation of Cygnus. And sort of to the lower right a little bit is the star Altair and Aquila the Eagle. And those three together are the summer triangle. And you can see the Milky Way running right through there.
Michael, I'd like to ask what causes those dark patches in the Milky Way. They're really noticeable in this picture.
Well, they really are, and you can see them with the naked eye as well if you get out of the city again, like we were talking earlier, into a really dark sky. And what that really is foreground dark clouds of gas that are in the foreground. You can't really see them except where they're projected against the background stars, millions of stars beyond in the Milky Way. If those dark clouds weren't there, you could see the entire Milky Way as a more or less homogeneous white band around the sky. And so that's a really good demonstration of the fact that there's an enormous amount of dark, invisible matter in our galaxy.
In fact, we cannot see the center, the real core of the galaxy because of all this matter in between us.
Well, that's right. Terry, I think we can see maybe only about 10 or 20% from where we are toward the center of the galaxy.
Yeah, I once did a calculation of how bright the center of the galaxy would be given the number of stars there compared to how bright we actually see it. And the calculations came out, it would be so bright that it would be comparable to the full moon. You could read a newspaper under the light from the core of the galaxy.
Are you saying that if instead of the sun being in the plane of the galaxy, if we were, say, up above the plane, we'd be able to see down into the center and then night would be as bright as the full moon?
Yeah, possibly. More of what I was doing was just eliminating the effect of all those dust clouds that caused, if they weren't there and there were only stars, and the starlight was not blocked by those dust clouds, it would be enormously brighter. And the effect shown beautifully in Michael's picture here of the real clouds is to patch up that Milky Way into a sort of almost like a spine.
Yeah, that's right. They used to call it the backbone of night.
Yeah.
Didn't it look like a spine?
Exactly. You can see that as well in the next photograph here, which is a bit more of a close-up. This is taken with a standard 50mm lens on very high-speed film, but it's about a 15-minute exposure. And here we can see Cygnus the Swan, two of the bright stars of the summer triangle, with Vega off to the right. And Terry, you can see exactly the same thing.
Yeah, outstanding picture.
And you'll be able to see just over to the left there a little red patch. That's called the North American Nebula, and we'll take a look. It's one of the best objects in the summer sky. We'll take a look at a close-up photograph of that later, and a third photograph between the constellation of Cygnus and the constellation of Cassiopeia. Cassiopeia is a very prominent constellation. Almost everybody knows it. It's a familiar little W that rises to the northeast later in the evenings, and this is the portion of the Milky Way that runs between Cygnus and Cassiopeia. It's just beautiful. It's so exciting to be out in a dark sky if you're on holidays up in Muskoka or someplace away from the city, Terry, and you get it virtually every night where you live.
I feel fortunate, more so all the time, from the number of people that I talk to that say, heck, I just can't see this stuff from where I live, and I have to go on an expedition to see it. And I guess it's going to get more that way as time goes on. The people are just going to have to go farther and farther from the cities to see it. But it's worth it.
Yeah, that's one major concern I have going into the 21st century, is that things like the Milky Way and dark skies will more or less be eliminated unless you do travel to uninhabited areas as big as, say, Australia. Because all of southern Ontario is more or less awash in light right now.
It is. Algonquin Park and the area up in cottage country is still pretty good. But you know, it's gradually disappearing too. And I think one thing that is doing it more than anything else are dusk to dawn so-called security lights on private homes. One of those destroys the sky for thousands of feet, probably almost up to a half a mile in some cases, depending on how many trees there are to block it. But those lights tend to be probably the worst designed, in that the light just goes in all directions from them. And a good portion, probably 30%, is going up into the sky. Another calculation on those kinds of lights is you can observe them from miles away, and they'll be brighter than the brightest star in the sky, which means you're getting competition from those lights a long way away. And when they're out in the middle of nowhere, like on a farm or a cottage or something, it just takes a few of them to really begin to wreck things. And
It's a real shame.
I don't know what we can do about it, but it's getting worse all the time.
A couple of things that you can see in the summer sky when you do manage to get into dark skies are two of the objects that we're looking at in the next couple of photographs. This one is a close-up of the North American Nebula. It's obvious why it's called that from its shape. And the pinkish or red glow is a fairly good representation, not of what you see with your naked eye, because the eye is not sensitive to color at low light levels, but with the photographic film you can pick up the red, which is caused by hydrogen gas. And this particular nebula, called the North America, is illuminated. It's actually glowing gas that is illuminated by the bright star Deneb, which is off to the right side in this photograph. And it's one of the great objects of the summer sky.
Take a minute, Michael, to tell us how you got such an incredible photograph, because I should mention that you took this.
Well, this photograph is taken with a special kind of camera that actually looks like a telescope, but it's called a Schmidt camera. It has a mirror that is 20 centimeters or 8 inches in diameter, and it's a very fast mirror with a very deep curve, and it projects the image onto a curved film. It's an extremely sharp camera, extremely high resolution. And as you can see from the pinpoint star images, I mounted piggyback on top of another big telescope, and then the telescope itself has an electric motor that turns to follow, to compensate for the Earth's rotation, to follow the stars as they cross the sky. And this photograph is about if I recall, about a 15-minute exposure, taken onto color film, and then to increase the contrast and the intensity, I take that original slide and then duplicate it using a slide duplicating mechanism onto another film, and that just brings out the color even more.
But light pollution is going to make it more and more difficult for you to take these photographs.
It really is, and I found that even in the last 5 years, from Muskoka, as Terry was saying, it's becoming more difficult, and I find that to do really, really good serious stuff, I mean, it sounds silly and crazy and incredibly expensive, but I've got to go to Australia, and that's what I'm doing.
Next photograph is, I believe, another shot that you took with this camera.
Yeah, that's right. Now, these Terry and Randy, these are just fabulous objects. The large one here is to the lower right is called the Lagoon Nebula, and then there's a smaller one to the upper left called the Trifid Nebula. And these are great objects. You can actually see the lagoon with the naked eye, and they're great in binoculars or almost any telescope. Terry, you've seen them thousands of times, I'm sure.
Indeed. Binoculars are the most underrated piece of astronomical equipment. You can see these things and patches up and down the Milky Way of nebulosity and star clusters. It's just, it's really terrific to be able to begin to know what they are and how far away they are. And you say, here's my binoculars, and I'm seeing nebulas buried thousands of light years away in galaxies millions of light years away.
Well, that's something that I think, people who come to me, and I'm sure you too, they ask, well, what size telescope should I get to start out? Because I'm interested in learning more about amateur astronomy. Of course, we all say, get some binoculars first, because you can see so many things, as you say, but also, if the interest wanes, you've always got a nice pair of binoculars for sporting events or bird watching or whatever. But people they underestimate the quality of what you can see through binoculars.
$150 or $200 on binoculars will be far better spent than a similar amount of money on a telescope. You've got a more versatile piece of equipment, something that shows many astronomical objects, comfortable to use, small, take anywhere. Really, I agree with you totally that that's my recommendation.
This is probably also a good time just to mention a couple of other things for people who might be interested in getting out in the warm evenings, who've never really looked at the stars before. A couple of things that they can do to help themselves learn about all of this. One is to get the publication called the Observer's Handbook of the Royal Astronomical Society of Canada. The Observer's Handbook is well known and well respected throughout the world. It's got all sorts of information about what you can see in the sky and what's visible. If you get the Observer's Handbook and then a fairly simple star atlas, which you can get for about $20, and a pair of binoculars, get out into dark skies. Boy, just with that equipment, Terry, you could have a lifetime of fabulous observing.
I should mention that membership in the Royal Astronomical Society of Canada is $25 for a year. You not only get the Observer's Handbook, but you get to attend meetings that are held at the McLaughlin Planetarium twice a month. And also, we have evenings when we go out with members and do some observing with telescopes and binoculars. And if anyone's interested in finding out more information about the Royal Astronomical Society of Canada, they can give us a call. Our number is in the phone book, and also they can write to us, care of the Planetarium. We should thank the McLaughlin Planetarium for allowing us to hold our meetings there during the last 20 years. RASC really appreciates their help.
I think probably that wraps it up. I think, Randy and Terry, we could go on for hours about the summer sky, but we recommend do get out into a dark sky if you can. Get out of the city and take a pair of binoculars and a nice lounge chair, and you'll just have a terrific time. So enjoy the summer sky.
Thank you very much. One incredible thing that you may see this year, which we were treated to in March, is the possibility of seeing northern lights. Terry, you brought a few slides of a northern light display that you saw in March. Tell us what you saw.
I did. We'll start off with this, which isn't the northern lights, it's the sun. And the sun is responsible for northern lights. I hear still, many times, that northern lights are caused by reflections of sunlight off the polar ices. And the sun has something to do with it, but not that. The sun is being, it has, here we see in this picture, massive sunspot. And this is the one that caused the aurora on March 12th and 13th, which was the best I've seen probably in my whole life. It's certainly equal to the best I've ever seen. And that sunspot is an area of intense magnetic disturbance on the sun, where the radiation from the sun normally flowing out is twisted and contorted and sometimes bursts out in what's called a flare. And when that happens, the actual material of the sun is thrown off the sun and emerges as a cloud. And if the Earth happens to be in the direction of that cloud, the cloud comes and gets wound up in the Earth's magnetic field and funneled by magnetic field lines over the poles. And when that solar material, protons and electrons mostly, comes into the atmosphere, it has an electric interaction with the atmospheric atoms and molecules. And the result of that is light. And the light can be magnificent, absolutely beautiful. This is the March 12th this year aurora. And it was so bright that the moon is in the lower left part of this picture, and the aurora is overpowering it in its brightness.
Unreal.
It's an amazing phenomena. This particular aurora was intensely red. And around 1:30, here I am outside my house, going nuts with the intensity of this display. It was just magnificent. The reds and the pulsating lights and the curtains, it was all over the entire sky, so bright at one point that I could see the settings on my camera, like in full moonlight. And it was lighting up the snow. Sometimes the snow would be purple and other times green. Absolutely stunning.
Really a display of a lifetime.
It surely was, and something that I just wish more people could have seen.
Randy, I'm going to interrupt Terry because I know he's not going to say it about his own photograph, but I think our viewers should know that these photographs are just among the best aurora photographs that have ever been taken. They are truly superb, and Terry, I mean, just a great, great achievement.
I feel I was at the right place at the right time. Because and I waited for the peak. It was about 1:30 in the morning, and I wasn't going to go to bed. I was up till 3:30 and crawled into bed after that as it started to power down. But it was astounding. And the point I'd like to make, two, I think. One is that auroras can't really be predicted. We know that sometimes there's big sunspots that can produce these things, but sometimes they do and sometimes they don't. Sometimes the flares do and sometimes they don't. So the best thing to do is simply to go out whenever you can and check out the sky. Try to make it an evening habit to walk the dog or do something to get outside and just see what's going on.
What direction should they look?
North mostly, but this aurora was over the entire sky, but north is the general direction to look. And if you've got a way to look to the north without too many lights interfering, you should do it. Because the second point is that we are now coming towards sunspot maximum in the latter part of next year or early 1991. This is an 11-year cycle that's coming up to a peak now, and it is surging to a peak. We are probably going to get the highest or the second highest number of spots and intensity of spots on record, and that means lots of auroras. Already this year I've seen probably at least 6 reasonably good auroras, including this spectacular one.
And this, we should note that this incredible aurora that Terry saw was visible in Toronto. Michael, you were at Bayview, Eglinton area. You saw it.
Well, Randy, I was in bed. I'd had a tough day, and you called me on the phone and said you got to get outside. So I just, quickly threw on something. It was freezing cold. I didn't have many clothes on. I went outside, and it was red. It was unbelievable. So it really was spectacular.
Get out and look for aurora.
For people who are interested in the term aurora, we keep using northern lights. Aurora Borealis is the Latin term that means northern dawn. Aurora meaning dawn and Borealis meaning north. And theoretically, of course, aurora is visible in the south as well, the Aurora Australis, although the land masses are much closer to the equator there, and so you don't see them very often from the southern hemisphere.
One thing that we can predict this summer is a total lunar eclipse. It is going to happen on Wednesday, August 16th. And Michael, tell us a little bit about what we can expect to see.
Well, this is going to be great. Everybody, I think, probably has seen or remembers, at least has seen a photograph of an eclipse of the moon. And more often than not, you get partial lunar eclipses rather than total ones. And it's been some years now since we've had a total lunar eclipse visible from our hemisphere. They happen every couple of years, but sometimes they're visible from the Pacific hemisphere. And what we're going to see here is a total eclipse of the moon that occurs on Wednesday evening, the 16th of August. So mark that on your calendars. It's Wednesday the 16th, and it's conveniently timed. I would like to say that the Society can take credit for that, but it's conveniently timed to happen in early evening. And what we have here is a diagram, a schematic diagram showing the moon as the small disk moving from right to left, sort of up toward the left, through the Earth's shadow. The shadow cast by the Earth out into space behind it. And we have 2 concentric circles there. The dark one in the center is the umbra of the Earth's shadow, the dark central portion of the shadow, and then the lighter one, the outer shadow called the penumbra, which is the lighter shadow in which the moon starts to appear slightly shaded. And we can see here the progress of the moon through the shadow. The dark portion of the shadow first strikes the moon, or to put it the proper way, the moon enters the Earth's shadow, the darker portion, at about 20 minutes after 9 p.m. Eastern Daylight Time. And that's when, just a few minutes before that, you'll notice some real noticeable shading on the upper left corner of the moon, and then you'll be able to see the fairly sharp shadow of the moon slowly crossing the lunar disk until at about 19 minutes after 10 p.m., the moon will be in total shadow and it will be totally eclipsed. This is an extremely long total eclipse. The total phase of this eclipse lasts 1 hour and 38 minutes, which is extremely long.
So did it take an hour for the moon to get into the shadow? And,
Yeah.
And then we'll be in for 1 hour and 20 minutes?
Absolutely, and
Wow.
this, I mean, it gives a graphic demonstration of a number of things. One is the actual physical movement of the moon in its orbit around the Earth. You can see that within an hour. Second, it gives a really good indication of the size of the Earth's shadow. And because you can see the curved shadow, the shadow crossing the moon is curved, this is one of the great demonstrations of the fact that the Earth is spherical.
Michael, we've got a photograph here taken by a Japanese astronomer which depicts that exactly. I think it's a wonderful demonstration photograph.
This is superb. Obviously, this is a multiple exposure. And in this series of photographs, the moon starts on the right side, just in the penumbra of the shadow, and then at about 20-minute or half-hour intervals, the moon is photographed as it enters into the umbra, the dark shadow of the moon, and then it emerges on the other side. Now, one thing that's very interesting about this, and Terry, you've seen them, I know, and Randy, you have as well, the moon does not usually disappear entirely during the total phase of an eclipse. It becomes extremely dark, but usually in most eclipses, and this is to some extent unpredictable, you can see the moon and it glows with a kind of copper or reddish glow. And that, of course, as we know, is caused by refraction of the sunlight through the Earth's atmosphere. It's refracted and bent into the shadow cone, and because of absorption by dust in the Earth's atmosphere, the light that is refracted into the Earth's shadow cone is slightly reddish, and so very often it makes the moon appear reddish. But Terry, I mean, we know that in some lunar eclipses in history, in recent history, there's been so much cloud and dust in the Earth's atmosphere that the moon has seemed to disappear completely.
In 1960, Randy and Michael, I blew it. There was a total eclipse, and I knew there was a total eclipse, and I was studying for an exam in high school at the time. And I was torn between going outside and looking at the eclipse and stuff. And I went out, and I took a quick look, and there was nothing there. I figured it's got to be cloudy, and I went back in. And then I heard the next day that this was one of those extremely rare eclipses where the moon was blocked out completely. And so I missed it, and I was determined after that I was never going to miss a total eclipse again. And I have seen one that dark since, but it's wonderful the way they vary. Some of them it looks like a copper penny up there. Sometimes they even have a gold color. Other times a deep, rich brown. And it varies during the eclipse because of the intensity of the shadow in which the moon has entered.
Well, we'll look forward to seeing what happens for this particular eclipse. We're planning, Astronomy Toronto will plan to telecast that eclipse live on Wednesday, August 16th, between the hours of 9:30 and 10:30. So we won't be here in the studio at York Mills. We'll be out in the back in the parking lot, and we certainly hope that you'll be able to join us. We'll be back in just a moment to talk more about amateur astronomy and some of our favorite slides. But first, join us with a bit of reminiscing. This July 20th is the 20th anniversary of the first moon landing. Take a look at Apollo 11, and we'll be back in a minute. Stay with us.
Six, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Roger, Eagle, contact. Roger, how does it look? The Eagle has wings. Roger. Eagle, we got you now. It's looking good, over. Roger, copy. Eagle, Houston, after yaw around, angled S-band pitch, -9er, yaw, +18. Roger, you're a go to continue power descent. You're a go to continue power descent. 4 forward, drift into the right a little. Contact right. Okay, engine stop. We copy you down, Eagle. Tranquility Base here. The Eagle has landed. Yeah, I'm going to step off the limb now. That's one small step for man, one giant leap for mankind. President John F. Kennedy's message to Congress of May 1961. I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to Earth. That has been accomplished.
Welcome back. Well, that just gives you a few views of the Apollo 11 mission, which took place 20 years ago, if you can believe it. What we're going to do now to finish up the show is show a few of our favorite photographs, astronomical photographs, and maybe talk a little bit about why each one is our favorite. Being the host, I get to go first. My first picture is one of the moon. I've always found the moon to be an always changing object. As an amateur astronomer, being able to look up at the moon every night and see it differently has always been a treat for me. It's always an excellent object to start off with when you're beginning in your amateur astronomy, because it's always changing. You can look at it with your naked eye. This is a naked eye view of a moonrise, but also through telescopes and binoculars. It always presents a different view. One view of the moon that is rather unique is when it passes directly in front of the sun. Michael and Terry and I have all seen total eclipses of the sun. They're rather rare, more rare than a lunar eclipse, because if you can see the moon during the eclipse, then you get to see the eclipse. But for this particular solar eclipse, we were down in Papua New Guinea, and it was just an extremely fantastic, dynamic, ever-changing event, and really something that everyone should get to see at least once in their lifetime. The next total eclipse of the sun, visible from nearby Canada, is through Hawaii and Mexico in 1991, and the Royal Astronomical Society of Canada is planning an expedition to go see that eclipse, and certainly everyone is invited to join us. My next favorite photograph is a planet. I wish I'd been able to take this photograph, but unfortunately I can't take the credit. Saturn is the most beautiful object, I feel, through a telescope. Everyone remembers their first view of Saturn through a telescope. This perspective is a little bit different. This was taken by the Voyager 1 spacecraft in 1980 from about a distance of 6 million kilometers, looking back, and you can see the shadow of the ball on the rings. And I still think this is the photograph of the century. I don't know about you guys, but it's a wonderful photograph.
Well, I have a challenge for that in my first photograph. This one vies for the photograph of the century as well. And also, this is, like you, I would have liked to have been able to take this, and this was taken by humans rather than a robot explorer. The moon over, rather the Earth over the moon as viewed from lunar orbit by the astronauts, the Apollo astronauts. And this represents to me our spaceship, our home in the universe, the platform from which we have the opportunities to look out and explore the universe. And the next picture shows something that is visible from the surface of the Earth, and that's looking back toward the moon and seeing, you were just mentioning, Randy, the interesting different phenomena that are visible on the moon, and here is one. It's called Earthshine. It is the sunlight reflecting off the Earth and off the dark side of the moon, the night side of the moon, and illuminating it. And it's picked up in this picture when the moon just happened to be next to the most beautiful star cluster, the Pleiades star cluster. And this just occurred in April of this year. And we got an opportunity to see it and photograph it. And those kinds of things just have an intense beauty. And my final of my three selections is a shot from my yard. And to me, it shows the constellation Orion, and off to the right in this picture is the Pleiades with the planets Mars and Jupiter beside them. And it just represents to me and shows what the sky means, the beauty of the night sky.
Michael, you have your selection?
Well, I suppose being an astrophotographer, I am really impressed with the beauty of the sky as it can be captured on film when one can then contemplate it night after night or day after day. I am particularly impressed by the colors in the sky that are elusive and that the human eye really can't see. and color film, when it's guided patiently by an astrophotographer over a half-hour or 1-hour exposure, can demonstrate the colors in the sky. And this is a very good example. This is called the Dumbbell Nebula. It's got a number. It's called M27. And to me, this photograph makes it look just like an apple core, because you get all of those colors, the red on the outside, and sort of green and white on the inside, and right in the very center of the Dumbbell Nebula. This, by the way, is one of the easy objects to see in the summer sky. And I think every astronomer, in the first 5 minutes of setting up in any summer evening, looks up and just checks out the Dumbbell Nebula just to reassure him or herself that it's there. And you can see the central star right in the very center that illuminates this gorgeous glowing cloud of gas that's being thrown off progressively from the star. It's a beautiful object. The second photograph I've chosen is taken from a long way away, halfway around the world, and this was again in April of 1986, when a number of us went down to Australia to observe Comet Halley when it did its closest flyby and closest approach to the Earth. And here we see two tails. Comets don't necessarily just have one tail. Comets have two tails. We've got the sort of a very prominent thin blue tail to the right, and then a sort of fan-shaped dust tail that is off toward the left. And the interesting thing about this photograph is that the stars are seen as streaks on the film. And the reason for that is that during the half hour required to photograph the comet, it's moved against the background of stars. So I had to follow the comet, and the stars appear as streaks. But it's just such an exciting event to witness. And then finally, we have something that's quite closer to home, and something that you can see 2 or 3 times in every year without any fancy equipment at all. This was taken in April of 1988 from Muskoka. It's a view just after sunset of the brilliant planet Venus, which is, when it's visible in the sky, is always the brightest object in the sky after the sun and moon. And then below that, just above the horizon, to the right of the tree that is in silhouette, we see the very elusive planet Mercury. And I think this photograph, to me, typifies a number of things. It starts to explain the spirituality of being an amateur astronomer. It demonstrates a little bit about our place in the solar system with the other planets and our sister planet Venus. Being an amateur astronomer is a sublime treat. And that's what these photographs, I think, we want to convey by these images, our favorites.
Terry, I guess these photos show that any amateur astronomer who goes out at night, every night is a different experience.
Mm-hmm. Very much so. We haven't mentioned much about mathematics or astrophysics here. We've talked about the romance and the beauty of the night sky. And I think that's the key to it, because once you come to know the sky and understand its workings, it's presenting to you a new tapestry every night, a new opportunity to see something you've never seen before, or to review something that you have seen before that is worth looking at again. And you almost get a friendly relationship with the sky, where you can go out and you can say, I know this place. I can explore it myself. It's personal exploration and discovery again and again that you can do yourself.
The nice thing about the whole experience, Michael, is it can be totally free. There's a lot of things changing, and there aren't lasers and Star Wars and all that kind of thing that you might see in a movie theater, but you're looking at real life, and it's a free experience.
Well, this is one opportunity where, as you say, for free, doesn't cost a penny, you can go out and stand in the presence of a masterpiece, an original, and it belongs to everyone. And what a fabulous treat! Just a great treat. So I think the message we're trying to give here is, do it by all means. You'll be incredibly enriched by the experience.
Well, it's been a real treat today to have both of you here to share the excitement of amateur astronomy. Terry and Michael, thank you very much for sharing your experiences and your extraordinary photographs with us. We'll be watching, Terry, your column every week in the Sunday Star, The Universe, on the science page, and thank you again for keeping us informed.
Thanks a lot, Randy.
And to you, thank you very much for again watching Astronomy Toronto. Just a little on a personal note, it's been 9 years that Astronomy Toronto has been here on Cable 10. I remember making the first show in January 1981. And this is the 59th show here on Rogers Cable. Our August 16th, 1989 live lunar eclipse show will be the 60th Astronomy Toronto produced here on Rogers. Rain or shine, we're going to present the lunar eclipse to you, maybe through a cloud bank, but we will be on Rogers Cable on Wednesday, August 16th. But at this point in time, I'd like to thank Rogers Cable for giving us this opportunity to bring astronomy into your homes. It's been an enlightening experience. I've been able to do things personally that I would not have been able to if I hadn't been given this opportunity. During the 60 shows, we've had guests from the Royal Ontario Museum McLaughlin Planetarium. I'd like to thank the staff there for helping out. The University of Toronto Astronomy Department, the astronomers there have been quite helpful, and all the literally dozens of guests who've been here on stage with us, I'd like to thank very much. And also the people behind the cameras and up in the control room. They're all volunteers, all friends of mine and from the Royal Astronomical Society of Canada. It's been a wonderful experience. We may do it again sometime, but for now we're going to be signing off on this Astronomy Toronto. Thanks again. My name is Randy Attwood. Clear skies and keep looking up.